everyone, and welcome to Mphasis AWS Webinar. Today we'll be talking about how active learning helps build a usable machine learning model faster. It is now my pleasure to introduce today's speakers. Vibha Bakshandani, AVP of AI Cognitive Solutions for Mphasis Next Labs. Vibha has 14 plus years of cross-function experience in the technology industry. She has been actively involved in the research and development of natural language processing projects and is responsible for solutioning and building IP components as well as proof of concept for Mphasis clients. And we have Manish Shukla, Senior Associate Analyst for Mphasis Next Labs. Manish has extensive experience in the fields of text analytics, natural language processing, computer vision, email order processing information, and retrieval from unstructured documents. Vibha and Manish are both part of Mphasis Next Labs, which is the applied research and innovation arm of Mphasis, focused on cloud and cognitive initiatives and projects. And we also have Shashri Kapoor, Global Machine Learning Marketplace Lead for AWS. Shashri brings over 15 years of cross-vertical industry experience in innovative product and practice development. He is responsible for driving overall GTM strategy to accelerate customer adoption of pre-trained machine learning model packages and algorithms developed by third-party sellers. To get started, let's go ahead and hand it over to Vibha.
Thank you so much, Cecilia, for the kind introductions. Let me get started with setting the agenda of today's call. So we'll start with telling you about what are the different machine learning methods available. Then talk about what is data annotation, its importance, and the challenges that you face while doing data annotation. Then talk about active learning in the pretext of data annotation and supervised learning. Talk about various different methods of active learning available. Share some experiments as well as case studies where we have practically implemented active learning and some observations in terms of key takeaways. After that, we will move on to talking about AWS Marketplace, where different machine learning listings are available for you to subscribe and experiment with. And towards the end, we will open up for Q&A. So without further ado, let me get started with talking about the different machine learning algorithms available. As some of you already from the space of AI and machine learning would know, there are three types of machine learning algorithms: supervised, unsupervised, and reinforced. So supervised learning is where you explicitly specify the input and output to the algorithm, and that is what it learns from. In this case, it is called supervised because the human is guiding the algorithm by giving it a specific output corresponding to a particular input. Then we move on to unsupervised learning, where you are specifying the input to the algorithm, but the output is what it discovers on its own and explores. This is more applicable in case of clustering or association rule mining kind of algorithm. What you mean by clustering is when you group the data depending on certain properties and parameter. Say, for example, you're grouping customers on their purchase behavior, or you're grouping students depending on their subject of interest. So those are different examples of clustering. And the third type of learning belonging to the paradigm of machine learning is reinforced learning, where an algorithm learns from a reward and punishment behavior. It tries to maximize its reward function. Whenever it predicts a data point that is incorrect, it kind of gets punished. And whenever it predicts correctly, it gets rewarded. You find a lot of applications of reinforced learning in the realm of video gaming space, but it's an emerging field and there are other applications that are emerging as we speak. Now, having set the stage as to what the three learning algorithms mean in the context of machine learning, the most widely used and enterprise-wide adopted method is supervised learning. There's a lot of research out there from Gartner as well as other analyst firms that talks about why supervised learning is the method of choice when you go on to start adopting AI in your enterprise. One inherent reason behind this is because these algorithms are guided by a human. They embed the human knowledge in the most explicit way, and that is why they are more accurate and reliable. But since the human is guiding an algorithm in supervised learning, This guidance is what is provided by a mechanism, what we call as data annotation. So data annotation in very simple terms means labeling a data point. In the context of image classification, what this could mean is a person is looking at an image and identifying what are the several objects present in it, whether it is a scooter, a car, a toy. So this is in the context of image classification. If you're talking in the context of text classification, let me give you an example of a sentence which reads like, I was really excited to see my mother yesterday. Now, as a human, you know that the context and the sentiment in this sentence is positive. So when I provided that guidance that this sentence contains a positive emotion, that is what you mean by labeling in this context. Now, talking about data annotation in a context that all of you would have done so far is captcha authentications. So it not just prevents your websites from automated bot attacks, it is also capturing a lot of information and a lot of labeling from people across the world. So it's kind of a crowdsourcing method of data annotation. Data annotation is so important that there are organizations built on the mechanism and the business model of annotating data. So if you do not have resources within your organization to help you tag data and give that bandwidth, then there are different services available that can help you do so. Two such services also made available by Amazon are Mechanical Turk and Amazon Ground Truth that gives you the right interface to build for data annotation, as well as it helps you crowdsource resources from across the world that can help you with your data annotation activity, which is also known as data labeling or data tagging. Now, with any manual activity, because the human needs to sit and guide the algorithm and mark or label these points, it is time consuming, it is effort intensive and boring. Like all of you would agree, any task that is effort intensive, it is also prone to human errors. So how do you kind of get to work around this challenge of data annotation? Because in case of building machine learning algorithms, it is not just the quantity of data, sometimes it can be thousands of data points, or sometimes it can be even million data points, depending on your use case. So how do you get to that starting point where you have enough data points to start building your machine learning model? And this actually is a roadblock that many organizations are facing these days to start to adopt AI in mainstream application. So this is where active learning kind of comes in play. So I'd like to first explain about what active learning means in very simple terms. Like all of you would have sat through classroom trainings where typically the medium of instruction is one way. It's more passive information absorption that, a teacher is delivering the information and the students are learning from it and absorbing it, as opposed to an active method of learning where there is an interaction between the teacher and the learner involved. So case study discussions, peer-to-peer discussions, even group studies, they are kind of examples of active learning. And as many of you would agree, active learning methods are more effective because you retain the knowledge much faster because there's an interaction involved. So now let's speak about active learning in the context of machine learning. So if we have to draw a parallel of active learning to the machine learning world, in this case, your learner is the model and your trainer or the teacher is the human. And there is an interaction that is happening between the two. So if I have to explain the simple steps involved in active learning, you start with a large corpus of data which is unlabeled, which means there is no output specified for that data points as yet. You run it through the right machine learning and active learning method. Once your active learning method chooses the sample points that need to be labeled at priority, only those are the label points that you would provide to your human annotator to label them. And once the human has labeled them, you build a machine learning method based on that and you get your output model. Now, this is a one-time iteration of active learning. However, it has to be done iteratively. So if you take your focus to the flow diagram below, once you build a model, you have to monitor how accurate your model is. If you are satisfied with its performance, then you go on deploying the model. But if you see that there are areas of improvement where there are certain predictions or data point and patterns that the model has still not learned, those are the ones you select at priority in your second round of annotation. And those are the ones you give to your human annotator in your second round. And you build your model again. So this is an iterative and an interactive exercise that active learning enables. Now, some of you would ask, where do we start adopting active learning and where is it applicable? So the good news is it is applicable in both cases. If you are kind of starting afresh with adopting AI for your enterprise and you want to start building machine learning algorithms from scratch, it helps you select the right data points to be labeled upfront and labeled first so that you get to a machine learning working model faster. Now, if it's a working model, doesn't mean it's a perfect model, but it will reach a stage where you can start actually using it for your practical application. And the second stage where you can start adopting active learning is if you have already built a machine learning system, it is deployed, and now you are monitoring its performance. And if you see there is a drop or a reduction in its performance or accuracy, that is when you bring in active learning to select the right samples to be annotated, and those are provided to the model for retraining. Now, I would like to kind of shift your focus to a knowledge quadrant for machine learning, which will help you identify which method applies to you and get started from. So the way to look at it, this quadrant is, two-pronged. The first parameter to look at it is the knowledge that you as a human knows. And the second parameter is that the model knows that information and it has embedded that information in itself. The ideal scenario is you have already adopted AI and machine learning and you have a perfect, well-working model for your use case, which is the top left quadrant, in which case there is no role of active learning and you already have a well-functioning model. Now focus on the diagonally opposite quadrant of diversity sampling. In case you're getting started with the building a model, this is what you choose because there is no knowledge or there is no model as such at this moment. And you as a human have also not trained or selected any data points to be tagged. That's where you start with diversity sampling and start with choosing the most diverse sample that is the most representative of your business case. The second method of active learning is uncertainty sampling, which comes in play if you already have a working model, but you know that there are patterns that it has still not recognized and it can learn from. So a human can guide the model for those uncertain points and it can then start learning them and perform better. And the last or the third type of active learning method is known as transfer learning. So there are a lot of pre-built and pre-trained models already available out there that embed a lot of knowledge. So when you use these models to apply to your domain and transfer the learnings already incorporated into these models into your machine learning model, that is what is known as transfer learning. So with that, I'd like to hand over to my colleague Manish, who will take you through the various methods of active learning. Manish, over to you.
Thank you, Vibha, for explaining what active learning is and how it helps in machine learning framework. So before explaining the specific active learning methods, I would like to share a machine learning use case about classifying news headline data into predefined classes. The classes are like business, crime, education, entertainment, politics, and sports. So if you can see on the right, there is a snippet of the data where the text column contains the news headline and the category is the predefined user provided class. So for example, the third line which reads like Sharon endorses choice of Palestinian PM is classified as a data point belonging to the politics category. So if you want to build a machine learning model from here, so we can have two approaches. The first one is to randomly select substantial amount of data from the unlabeled data, annotate those data points and train a machine learning model. So with random sampling, user have control over the quantity of the data that he wants to select. And the second approach is like using active learning. So with active learning, what we can do is like we can select a very small amount of data for labeling build a machine learning model, and then by using active learning, we can do the targeted sampling. So with active learning technique, a user have control over the quality of the data as well as the quantity of the data. I'll be explaining this use case in detail in later the slides. Now, having this use case as an example, I'll be talking about the like the methods or algorithms used for active learning strategies. The first and the most famous active learning strategy is active learning using uncertainty sampling. So this active learning technique is useful when the machine learning model is uncertain or not confident enough to make a prediction. And if human feedback is provided in such a case, the overall accuracy of the model can be improved. So the active learning with uncertainty sampling helps in identifying the data points for which the model is uncertain to make confident predictions. So as you all can see, the diagram in the right depicts a binary classification machine learning problem with two classes. Let us consider it as a sentiment classification problem with the blue data points as a positive sentiment and the brown data points as a negative sentiment. So the dashed line in between is the separation boundary between these two classes, and it is called as a decision boundary in machine learning terminologies. The data point with question mark symbols are the ones where the model is not confident enough to classify them as either positive or negative sentiment. So these can be considered as a positive and negative sentiment with very low polarity score. So active learning with uncertainty sampling helps in targeting these data points falling near the separation boundary from the pool of unlabeled data so that they can be provided with human label and included in the training data, thus increasing overall accuracy of the machine learning model. Mathematically, active learning with uncertainty sampling assigns a confidence score to each data point, and based on this score, data points are sampled. So there are various methods to assign a confidence score, and least confidence and the margin of confidence are two such methods. Now, moving forward to the next algorithm, which is active learning with diversity sampling. Active learning with diversity sampling ensures that training data for machine learning model will have a diverse set of data points. So this kind of active learning technique is used to increase the coverage of the training data and ensure that all kind of features are data points are selected in your training sample. So let us understand it using an example and the diagram in the right. So suppose if you want to build a machine learning model that can classify news headlines into business and sports categories, but the news headlines are scrapped from a business newspaper. So majority of the news headlines will be of business category like the blue data points in the diagram, and very few will be of sports category like the red ones in the diagram. If we do a random sampling, the business class data point will have more representation in the training data as compared to the sports class data point. So if a training data is used for machine learning model training, it will be highly skewed towards a majority class, but we don't want our model to behave like that. So active learning with diversity sampling helps increasing the coverage of the data point in that sense. So it will help in like improving the sampling of sports category into the training data. So the difference between uncertainty sampling and diversity sampling is that uncertainty sampling helps where the model is uncertain to make prediction because data points are very close to decision boundary, whereas diversity sampling helps where the model predictions are incorrect due to lack of representation of certain data points in the training data. So there are various types of diversity sampling as well. Like first one is like model based outliers. So outliers are generally very few in numbers, and it is very difficult. It is difficult to have their representation in the training data if the random sampling is used. So model-based outliers, diversity sampling, what it does the targeted sampling for these data points. And then we have cluster-based outliers. So in cluster-based outlier diversity sampling, the unlabeled data is pre-segmented using clustering algorithms, and data points are sampled from each of the clusters. And then representative sampling helps when the output variable changes over time, and due to this, new data points have very less representation in the training data. The final and fourth diversity sampling is like real world diversity. So the real world diversity sampling strategy is used to incur fairness and support real world diversity in the training data. With the help of this sampling strategy, it is ensured that training data is as fair as possible and free from real-world biases, such as demographic bias or the gender biases. Now, then we have next algorithm, which is active transfer learning for uncertainty sampling. So it is like doing the uncertainty sampling using transfer learning. So for those who don't know like what transfer learning is, so transfer learning is the process of using knowledge gained while solving one problem and applying it to another related problem. So it can be understood as a, like, for example, deep learning models that are trained for an object detection task can be used for facial recognition purpose. Similarly, in the context of a natural language processing use case, pre-trained BERT models are available that can be used for specific tasks like sentiment classification or news headline classification. The basic idea of using transfer learning with uncertainty sampling is to use the pre-trained machine learning model to predict its own error. So let us understand it using the diagram in the deck. So here we have a deep learning model that can predict the data into 4 classes. As you can see, these are like label A, B, C, and D. In our use case, we can assume these as the predefined classes for news headlines data. So when the trained machine learning model makes prediction on validation data, each data point is classified into 4 classes. In machine learning terminology, the validation data is a separate from training data where the actual labels are known, similar to the training data. So after the predictions we have, uh, based on the predictions, like we can compare the actual and the predicted labels to get like which are the data points which are classified correctly and which are the data points which are classified incorrectly. So when this data with correct and incorrect label is used to train the same deep neural network, just removing the final layer and changing it as a binary classification neural network. And when this trained, this retrained machine deep learning model is used to make prediction on unlabeled data, those data points will be classified as correct and incorrect. So this way, model itself is predicting like, okay, these are the data points where the model will be making incorrect predictions. So if we sample the incorrect predictions with highest confidence and include them into the training data, that way the overall accuracy of the model can be increased significantly. Then we have the next algorithm, that is active transfer learning with representative sampling. So as discussed earlier, representative sampling is used when the output variable changes over time. So let us understand it using an example. Suppose initially deep learning model is trained only on news headlines of business and entertainment category data, uh, this validation data is also having similar distribution. Let's call it as a training domain data. But what happens over time, like unlabeled data also has sports category headlines along with business and entertainment. And we call it as an application domain data. To increase the representation of news headlines belonging to the sports category, this sampling strategy can be used because initially the sports category data was not part of the training data. So from the diagram, if you see, a deep learning model is trained on initial training data and predicts on validation data. Then the predictions are ignored and all these data points are labeled as training, like classified as a training by human. And then we sample a small amount of unlabeled data and label it as application. So when this new data is used to retrain the deep learning model, data points are classified as and retrain the deep learning model and used to make prediction on unlabeled data. What will happen? Each of the data point will be classified as a training or application by the model. So when from the pool of unlabeled data, so news headlines of business entertainment will be classified as training because they were part of the training data initially. But sports headlines were only can be classified as application because it was part of the application. Though business and entertainment will come in the application as well, but the confidence of them will be lower as compared to the sports because sports is only belonging to the application. So when we sample application predictions with highest confidence and if they are given human label and included in the initial training data, the overall accuracy of the model can be improved by having the representation of the new class. Then the final active learning algorithm that I will be talking about is active transfer learning for adaptive sampling. So it combines the features of both uncertainty and representative sampling. The architecture is like the active transfer learning for uncertainty sampling only, except one change, that is like after sampling incorrect ones with the highest confidence, they are relabeled as correct, and the process is done iteratively. So the idea behind idea behind this algorithm is like deep learning model will classify the unlabeled data as incorrect when the model is uncertain, and also when the data point does not have a representation in the training data. So in both the cases, deep learning model will predict them as incorrect. So by iteratively relabeling them as correct, will make sure they are part of the training data, though the actual labels are unknown at this point of time. And once the sufficient data points are sampled, then they can be provided with actual labels and can be included in the training data to increase the overall accuracy of the model. So this is how we can like combine both features of uncertainty and representative sampling. So moving forward, I'll be explaining the use case that I have started with. So for that use case, we have news headline data, and to do it using active learning, we have randomly selected 500 data points and labeled those into the classes like sports, entertainment, crime, business, politics, and education. Then we train a machine learning model and make a prediction on validation data. Then we get an accuracy of around 82%. So using this model and querying using the active learning, what we have done, we queried another 1,000 more data points from the pool of unlabeled data using active learning. So here we are like doing the sampling iteratively. Like instead of starting with a substantial amount of data, we have started with only 500 data points, and then we sampled 1,000 more using the knowledge from the machine learning model. And once we have the data points sampled using active learning, these data points are provided with a human label. And once these data points are provided with the human label, the machine learning model is trained incrementally. And when we have predicted is on the validation data, at this point of time, we were able to see an accuracy of 85.3. So we can see there is a jump of more than 3% accuracy by just like after having just one iteration of active learning. So after that, we performed again the same process again. We sampled 1,000 more data points, provided them with a human label, and incrementally trained the machine learning model. And after that, we were able to get an accuracy of 86%. So by two iterations, we were able to get get an increase in accuracy of around 4%. So as you can see, like we sampled around 2,500 data points, and we got an accuracy of 86%. So when we perform the same task using random sampling, in that experiment, we were able to get accuracy of 84% only, even less than that. So like, as you can see, like only 2,500 data points are selected in both the cases, but with active learning, we are able to get a better accuracy. And so now I'll request Viva to discuss the actual business use case where we have implemented active learning. And over to you, Viva.
Thank you so much, Manish, for sharing the different methods of active learning available. Now, I'd like to talk about a case study that we did for one of our clients in terms of a project that we developed for them. We were developing an AI-powered due diligence platform in the private equity space. The goal over here was to augment the research which was otherwise done manually by analysts. And we had to develop machine learning models to predict themes as well as sentiments from various customer reviews. So when we started this project, we had to build model for just one industry or domain. So at that time, when we started building the model, the client took around 1 month of time to gather the tagged data points and provide to us, for which we developed the machine learning model. And they collected around 20,000 data samples. So after we did that, we were able to get to a model of around 85% accuracy that was deployed. Now, the idea was not just to use this platform for one domain, but to scale it to multiple domains. The product roadmap of the project had around 15 domains that it had to scale to. But every single time we couldn't wait 1 month time to just get the data for that particular domain to even get started with building a machine learning model. So that's why active learning came in play, and it came in really useful to us. So what we did when we were moving and scaling our model and our system to the second domain, we started with a small sample, a 25% size sample of just 5,000 data points this time. And those were tagged in around 7 days. So the first model that we built using those data points, it had around 70% accuracy. And then using this information, we iteratively select only those data points for the second iteration, which were performing low, or where the confidence of the model was not great. So with this, we were able to iteratively build the model, select only few samples, tag a few set of samples, and get to a working model much faster. There was a scenario when the client had to deliver to his end customer deliverables, but we did not have a perfect functioning model with 85% plus accuracy. But since we already had a working model which was performing, good for 7 out of 10 times, it was usable and could be used to meet the end client deliverables. One important thing to note here is, since you are distributing the effort of tagging and also you are doing targeted sampling, there is much less chance of tagging fatigue, and the human error that you see in the data labels is also much lesser. So the quality of the data obtained was also much higher, which also kind of enabled us to perform machine learning training better, and the performance of the model inherently improved because of that. With that, I'd like to kind of wrap up on the concept of active learning and leave you with a few key takeaways. The first one being that even if you have a considerably lower amount of data, because of targeted sampling, you will be able to get to a usable model much faster. Since you're doing targeted sampling and selecting lesser number of data points, the effort that goes into building a model is reduced in terms of not just the time, but also the manpower that is involved. So that really helps you to kind of accelerate your process of building machine learning and artificial intelligence related algorithms. The second point I would like to highlight is that if you're using active learning to improve your model performance, then first it is imperative for you to understand why your model performance is deteriorating. And once you have identified the reason behind the same, that will help you shortlist the right method from the list that we have shared. One more point to note is that active learning by itself will not help you improve the model performance, because it only helps you select the right data points to be labeled at priority. But once you have labeled them and have them ready, then you need to use incremental learning to train your model incrementally and improve its performance. Now, some of you would say that I used active learning and it still did not improve my model further. It could be in cases where you already have a good functioning model. It is already at its saturation point of learning all the data points that are exposed to it, in which active learning is not really applicable to your use case. The last point that I would like to highlight is, if you are belonging to a business function where the data available for tagging is not with you upfront, but it comes in pieces and it kind of builds over time. Say, for example, transactional data of banks. You build the data over time. In those cases, you can still get started with, say, 1 month of data, build a model. Then for the next month, you can select the right sample and retrain the model. So it comes in handy even if you don't have a sizable or a large data set available upfront. With that, I'd like to pass on to my partner from AWS Marketplace team, Shishir Kapoor. Shishir, over to you.
Vibha, really appreciate it. And let me share my screen. So let's see how Mphasis allows you to use active learning directly and build models yourself. So I'm part of AWS ML Marketplace, and to set some context, we looked at the customer need for trusted machine learning models and algorithms from third-party and open source. And we looked at a couple of needs from the customers where they wanted to use these models very easily and test these models easily in their own environment without having any machine learning capability. Customers needed data security. So while they were using these machine learning models and algorithms in their own environment, they wanted to protect the privacy of their own data without having to share it with any external customers. And the third thing was how easily can they integrate these machine learning models and algorithms in their own machine learning stack that they have already built. And the same thing on the seller side, where sellers wanted an easy mechanism to deliver these models directly into the customer's account on AWS, but still protect the IP that they have built, and have a very simple mechanism to deliver and manage contracts with the customers while the customers were using these models. So what we came out with was Machine Learning Marketplace, where you can shop for pre-trained models and algorithms from third-party and open source, and directly deploy that within your Amazon SageMaker in your AWS environment, where you simply browse, subscribe to, and test and evaluate and deploy these models with a few simple clicks. So AWS Marketplace makes subscribing to and deploying ML models easy, where we're looking at, this is one place or a catalog to procure all kinds of ML models and algorithms, right from sentiment analysis to forecasting to image detection, object detection. Second is it natively integrates. So when you subscribe to and deploy these models, it natively integrates into your AWS services in your own account. It's very easy to manage these subscriptions from multiple models that you subscribe to. And AWS Marketplace manages the billing and the metering behind the scenes so that you can easily pay as you go to use these models, or you can ask for a private offer, which is a long-term contract from any of these sellers. Currently, we have about 600 plus machine learning models and algorithms, and 148 of those are from Mphasis. And we have about 60 plus software vendors deployed across 16 plus regions. So let's take a look at how you can use active learning very easily in your own AWS environment. So the recipe is quite simple. All you need are two algorithms from Mphasis, which is the active learning for text classification and text classifier with auto deep learning. The second thing that you need is the unlabeled data set of news articles, news headline articles, and a labeled data set of trained and validation that you would feed into the algorithms. So let's take a look at the steps. There are 4 simple steps here. First thing that you do is you go to AWS Marketplace, which is amazon.com, aws.amazon.com/marketplace, and you search for these 2 algorithms. You subscribe to them using a few simple clicks. And the third thing is what you do is, this is the part where you would use active learning to understand what part or how many data samples from this unlabeled news headline data set are the ones that you need to tag to be able to train this sentiment analysis model in the 4th step. So let's take a look at this. So the first thing that you do is, once you subscribe to this machine learning algorithm from Marketplace, it gets deployed as a container on your Amazon SageMaker, which is our Amazon's machine learning platform for building, training, and deploying models. And this runs within your own customer environment, where the sellers don't have access to any of the data that you experiment these models with. So your data is completely protected. So the first thing that you do is you label the training and the validation data set and feed that and run a training job for the active learning algorithm that you've just subscribed to. This in turn automatically creates a model, the active learning model, which would feed in the unlabeled news article data set that gives you, within your S3 bucket, the prioritized data that needs to be annotated. So you would take this data, you would give it to the data annotators, which will create a labeled data set of these news headline data articles. And then you would use this text classification algorithm to, again, separate the labeled data into labeled training and validation data sets, and again, run a training job in Amazon SageMaker using this text classification algorithm, which creates the text classification model, which then you can supply the unlabeled data set to create and find out what the sentiment of the news data article is. So essentially, once you know what the accuracy of this particular model is, you can repeat the process till you can improve the accuracy of that model. So it's a very simple 4-step recipe here without knowing anything about machine learning, you can start using these algorithms directly. And let me show you quickly how you can access and subscribe to these models. So the first thing that you would do is you would go to aws.com/marketplace. You can search here. You can look for active learning, and you would see the Mphasis machine learning algorithm. You would be able to see what the algorithm does, the product overview, the highlights, what version, what this, as you can see, this is an algorithm and not a pre-trained machine learning model, which is different. And then you would see the pricing of what the algorithm charges per hour, and the real-time inference as when you run the model. You can actually select the instance type that Mphasis recommends, or you can click another instance type that you prefer and that you're already running in your environment. And you can also see the infrastructure cost as you choose a different instance. Here below, as you keep scrolling, you would also see the instructions for using this model. Mphasis has provided the sample input data sets, output data sets, and also a notebook which you can run through. So let me just take you quickly through that notebook. Here, you would see the steps involved in running the active learning, which is step 3 here, to take the training data set, which is a labeled version of the unlabeled data set, and pass that training and validation data set through the algorithm, run the training job, and then pass the unlabeled data set through the model to be able to understand what samples do you need to annotate by the data annotators. So it's a very simple step here where you can just use this notebook to run this algorithm and create a training job and see what the output looks like. Here you would also see a training and a validation CSV sample data set along with the unlabeled CSV. As you can see, once you have the labeled data set or the prioritized labeled data set, you can simply click on the subscription button. So let me first take a look at the active learning. So if you would like to use this active learning algorithm, all you would do is continue to subscribe, and you would see what the pricing is and the charges are. And once you click continue to configure, you can actually create this training job. Once you click on view in Amazon SageMaker, it opens up the Amazon SageMaker within your console, where you can create this training job and start running this model. So similarly, you would also use the text classification model or the algorithm that you have subscribed to, and run that and create a training job to create the unlabeled or find out what the sentiment is. So that's an iterative process. And as you can see, the machine learning marketplace allows you to easily explore new use cases, run your POCs faster, reduce your time to data prep. And this is essentially where active learning comes in, where you don't have to label or sample all your data sets. Essentially, you're using active learning algorithm from Mphasis to really prioritize the data sets that you need to tag in order to train your sentiment analysis model. You could also use ML models from Mphasis to create synthetic features or extracting information out of your videos or your audio and increase your speed to production for any of the applications that you're building yourself. AWS ML Marketplace team helps buyers such as yourselves to understand and deep dive into your business challenge, where we can then recommend the type of models and algorithms that would be suitable for your use case. We can help along with the seller, along with Mphasis, we can help you with retraining or customizing some of the models and algorithms that are available on Marketplace. And then ML Marketplace also helps you with understanding all the different private offers. If you would like to go into a long-term contract, you could do so and request that from Mphasis and subscribe to that same long-term contract through ML Marketplace itself. Or you could choose to go in and select the public pricing and continue to pay as you go. So please feel free to reach out in case of any questions. And I would like to pass it on to Vibha.
Thank you so much, Shishir. I think that was really helpful to see the demo and how to actually use the marketplace machine learning algorithms. And if you are interested in subscribing in it, how to really go about it. So with that, I'd like to just leave you with a few reference and reading material about this topic. It is an emerging topic. There is a good amount of literature out there available. So do check it out if you're interested in this. And these are just a few resources where you can probably get started. There are also Mphasis resources available on this topic. And the listing that Shishir walked you through on the AWS Machine Learning Marketplace is one of them. We also have one of our platforms called BaseML, which is built on the principles of MLOps. Other than helping you develop a machine learning pipeline workflow and helping you with monitoring model performance, it also gives you a lot of features for active learning and helping you select the right method for sampling your data points. And if we have managed to spike your interest today, please do go and read the white paper available on Mphasis website about this topic. With that, we pretty much wrap the content that we wanted to deliver in today's webinar, and we can move on to any questions if they have come across in the Q&A window. Cecilia, over to you.
Thank you so much to our speakers. It looks like we have about 10 minutes left. We're going to be answering some questions submitted during today's presentation. As a reminder, you can still submit questions through the Q&A window. Okay, so our first question, can the same techniques presented be applied for different data types?
Okay, I can take that. So the answer is yes. Though we presented a lot of examples of text use cases, the same can be translated and also applied to any kind of data type, whether it is image, audio, video, or text. So yes, it can be used for different data types. Thanks, Cecilia.
Okay, we have our second question. In the case study, is active learning tried with multiple class or multi-label problem?
Okay, so we presented two examples. One was of the experiments that we conducted. In that example, it was a multi-class problem. And the client use case that we spoke about, that was a multi-label problem. So it can be applied in both scenarios, multi-class as well as multi-label.
Thank you, Vibha. And then our third question, can active learning be applied to regression or time series models?
Yeah, so Cecilia, I'll take that question. So there have been research. It's an ongoing field. So it has been applied to the time series models as well, but none of them have, as of now, performed very well. So right now it is very efficient for the classification problems. But yes, the research in this area is going on. Thank you.
Thank you, Manish. And then we have another question. How to decide the number of iterations of active learning sampling and retraining the ML model?
Yes. So, like the one way to decide the number of iterations is like if a machine learning model is able to predict the expected level of accuracy that is being set by the user or by the business, like for which you are developing the machine learning model. If that level of accuracy is achieved, then we can stop like iterating more iterations of the active learning. Or another way is like when the increase in accuracy in the successive iterations is less, and the effort that is needed to like annotate those data points is more. So in those scenarios as well, we can like kind of stop doing like performing this active learning thing. Yes.
Thank you. And then another question, how is my data secured?
I can take that one. So when you're actually subscribing to these algorithms from ML Marketplace, they get deployed as containers using Amazon SageMaker under the hood in your own environment in a network isolated manner. So what that means is that these containers are completely disconnected from the internet, where they do not have access to any external website or database, which they can pass your data out to. So all that these containers that are running on SageMaker are doing are taking the inputs that you're providing it through APIs and running that data through these algorithms and feeding that back to you. So they do not have, these containers do not have access to anything external to your environment, and hence your data is completely secure.
Thank you, Shishri. We have another question. What is the difference between active learning and reinforcement learning?
Okay, that's a really interesting question. I think whoever asked that was really listening in well. Thank you for that question. So the very first difference between the two is that they belong to different paradigms of machine learning. Active learning is more applicable in the supervised learning scenario where you're providing it guided input and output, whereas reinforcement learning is from the, is the parallel regime itself. It kind of is from different regimes, so they can't exactly be compared. Another way of looking at that would be active learning is a precursor to building your model. So once you have selected the right data sample and annotated that, that is what goes into building a model. So it's not really a training method, but it's a method of selecting the right data point. So that's what active learning is. And in reinforced learning, you do not provide labeled data points to your algorithm, but the algorithm maximizes the reward function whenever it learns from the reward and punishment behavior. I hope that kind of answers to some extent. Thanks, Cecilia. We can move on to the next question.
Thank you, Vippa. Our next question is, in the presentation, I saw 2 to 3 methods/approaches to active learning. Any thoughts on when to use what models, methods/approaches?
Yeah, Cecilia. So like, yes, as I was explaining, based on the use case to use case, the active learning algorithms can be used. Like while starting, like if you are trying to like start from the scratch, in those scenarios, like diversity sampling can help in like finding out the data points that are of diverse in nature. And if your machine learning model is not performing well in between, and you feel that it has something to do with the like uncertainty sampling, in those cases uncertainty sampling can be used, but this is not fixed actually. So if you remember, the transfer learning applies both of these scenarios together. So yeah, so all of these active learning strategies can be combined and used interchangeably depending upon what use case you are trying to solve. Another way to look at it is like using the knowledge quadrant. So knowledge quadrant also gives us information like what kind of challenges you are facing in your machine learning model, and based on that as well, the active learning technique or the methodology can be adopted. Yeah, thank you.
Thank you, Manish. And then another question, does text classification AL only use linear support vector model, or it detects what is best model for other models?
Yeah, so SVM or support vector models are not the only type of models that can be used to apply to your active learning methods. You can even use other deep learning methods, and how you select what is the best model for you is really data dependent and your use case dependent. It applies to both machine learning as well as deep learning.
Thank you, Vibha. And then how will I manage the underlying infrastructure?
I can take that. So essentially, when you're subscribing to these algorithms and deploying within your own environment, Amazon SageMaker essentially manages and scales the underlying infrastructure based on the demand, based on the volume of the data that you're sending to these algorithms. So you can simply auto-configure or auto-scale, and you don't have to worry about what instances and how many nodes that you want to attach to this particular algorithm to be able to handle the load. So essentially, SageMaker is doing that all for you under the hood, and it will create the instances, it'll deploy the container, It will run your training job, and at the end of the training job, it will deconstruct all of that, and so that you're not paying when you're not using this algorithm. So all of that underlying infrastructure is auto-managed. That is why we use SageMaker to deploy these algorithms in your own environment.
Thank you, Shishri. We have time for one more question. If you have any further questions, please reach out to the email ID provided on the slide. All of the resource links have also been shared in the chat window. You can go ahead and click on those if you need to. Our last question is, how can I get in touch with Mphasis if I need further help with these algorithms?
So
Yeah,
if you're,
essentially,
yeah, go ahead,
so
Shri. I'll add
yeah,
to
so
that.
you could actually go into the AWS Marketplace, ML Marketplace, like I showed. You can either reach out to Mphasis directly through the listings that they already have on the product page, or you could contact us, the same page, and we will help you get connected with the right folks in Mphasis. Go ahead, Vibha.
Thanks, Shishir. So yeah, I think you covered it. We also have our contact and support information available on all of the listings, and the marketing email ID that was shared with you in the previous slide, even that can be used to send in any queries.
Thank you, Vibha, Manish, and Shri for presenting. And thank you to the entire audience for attending today's webinar. In the next few days, you will receive a follow-up email with the link to the recording of today's webinar. On behalf of Mphasis, thank you for joining us today and enjoy the rest of your day.
Thank you, everyone, for joining.
Thanks, everyone.
Thanks, everyone. Yeah.